All right, let's get started with day 2. About 2 or 3 weeks ago in our notes we had something that looked a little bit like this. Ways to represent a problem algebraically. We've been working with some of these, so the algebraic formulas, we started being able to create those now by just looking at the data and seeing what we can do with it. The table, of course, we've got lots of tables of data. The verbal description, and we're going to see some more examples of that today, but basically what that means is we're describing a particular problem instead of like giving you things. For instance, I could say something like, start with the initial term a sub 1 equals 5 and add 3 to get each subsequent term. So it would be like 5 plus 3 is 8. Plus 3 is 11. So you could create that particular table or sequence using my verbal description. Concrete or pictorial, we've done a few of these. We did the Don't Fence Me In. You had the exploring houses and the building with toothpicks. All of those had pictures in them. Some of them had concrete things. Maybe you had actual manipulatives. Maybe you just had toothpicks or whatever, but there were concrete things that we were using to represent the problem that we were talking about algebraically. So for this week, we're going to lean into graphing. So graphing there is the 5th point of our star, and I would say that pretty much we already know a lot about how to graph the x, y's, and stuff like that. We're going to use our calculator for part of it. I'm really sad that this is an online class. This is one of the times when the face-to-face would really do you good, because one of the activities that we would do, and maybe you've seen it if you've been in our 361 and 362 classes, but if you haven't, there are some graphing things, activities with what's called a CBR. And if you don't know what that is, that's a calculator-based ranger. That's what that's called. Ranger. Okay. And this guy looks like this. This is an older one. Okay. It pops open here. If you have the older one, it's kind of nice because you can download the Ranger program using the 83, 84 button here and put it straight onto your 83 or 84. Or this one actually says 82, 83, but you can use it on an 83 or an 84. So you can download the program. You can push the trigger, and if I had batteries in this one, it was ready to go. A lot of times you would hear it start clicking. Tick, 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 tick. When you hear that sound, that means that it's actually collecting data. Hopefully I would have, let me find the hole, I would have connected this thing using a wire, a cable, to my calculator. And there's a couple of different kinds. One is just kind of looks like your headphones, and then the other one is the micro USB. So depending on what kind of a cable you have, you could use it to connect into your 83 or 84. And there's an entire booklet, I would say, if you're going to use these in your classroom, which I know that the Commerce Middle School here, some of their teachers use them in the classroom. Sometimes they borrow mine if they don't have enough. There's this one. This one's the original CBR. And then there's a CBR2, which normally has some white on the edges, but it basically works the same way. And you can see this little thing here. What it is basically it's like a motion detector. So when I flip this guy up and I point this at something, it's kind of like a radar cone for a radar, police officer, submarines, whatever, where it starts out here, but as it goes out, the signal widens. So you can see motion, and what it does is it sends out a signal and it hits a solid object and it bounces back. And so this thing is actually, it's a distance detector, I guess you should say. But for instance, if I have my hand right in front of it and then I move my hand farther away from it, it's going to say, hey, the distance grew between your hand and me, right? So the distance grew. So whenever it goes to put that onto my calculator, it's going to graph that, and it's going to end up being on an XY coordinate. So we have to think to ourselves, what's going to be the X, or the independent variable, and what's going to be the Y? So in other words, is the distance that my hand is the independent thing? Or is the time the independent thing? And in general, with very few exceptions, there are some exceptions, but most of the time, if time is one of your variables, it's independent, because I can't really control time, right? So the independent variable is time. How far my hand is depends on how many seconds you tell me, right? So if I start moving and you say, okay, time, however many seconds that was, maybe 2 seconds, well, this is the distance. But if I start moving again and you say time, well, this is the distance. Maybe that was t equals 5 seconds, or who knows. But depending on what time you tell me to measure, that is how far away my hand is. So there's a really cool activity. If you're planning to be a middle school teacher and you like technology, you might look into CBRs. Now, I'm going to tell you honestly, they're not cheap. You would have to probably have a grant, but if you're a member of TCTM, which you can become if you go to our camp conference in the summer, which is the Conference for the Advancement of Mathematics Teaching, and you can become a member of CTM here on campus, and then when you go to the camp conference, you can join the Texas Council of Teachers of Mathematics, TCTM. They have a lovely grant that they allow classroom teachers to apply for every year, and you can get up to $1,200 to purchase things like technology for your classroom, or help you pay for the camp conference, or whatever. So these are not cheap, but if you get them, I highly recommend you also get the little booklet that comes with them. Usually when you buy one, they send you the booklet for free. But they have all kinds of lovely activities. We use these a lot in our 361, 362, and in our 372 classes. So you will see them, the students in our classes, bouncing basketballs, or perhaps they're walking the line. So walking the line, that's one of the activities. It's one I want to kind of show you. And I really wish that we were face-to-face so you could have a CBR in your hand. I'm sorry. But basically, this down here would be time. And normally it's in seconds. And maybe it'll give you a 10 or a 15-second clip. And then up here would be distance. Okay. So if I had a graph that looked like this, and I'm just going to go up to 15, and I'm going to go across. I'm just going to go to 10 seconds. And you can get the feel for what the activity would be, because it's a really cool activity. And like I say, if you're going to be a middle school teacher, you might look into these things for the technology end of things. So if it went like this, and then it went like this, and then it went like this. Whee! Okay, notice that, by the way, this is a graph that the Ranger would load up on your calculator, and then it will tell you, walk this line. So notice that it is not a linear, it's not a quadratic, it's just some weird graph that they stuck on your calculator using the Ranger. And then it tells you to walk the line. Hopefully your first question is somewhere along the lines of, what kind of distance are we talking about? This is your starting point. This is where time equals 0, right? So in order to start my graph, I need to know about how far do I need to be out, right? So as you set up the CBR, you have the opportunity to choose. They usually default to distance in meters, but you could change it to feet if you want to. There are options in the settings that you can put it that way. So if I want to walk this line, And I have a friend of mine, a buddy, that's holding on to the CBR. Okay, they've got it hooked to their calculator. And they are measuring the distance between me and them. And I'm out here. Then how far should I be at the beginning of walking this line? I should be 10 meters, right? Probably it won't see me at 10 meters. So it's probably less than that. But anyway, and sometimes I have to try to walk the line because it doesn't tell me, by the way, over here how far that is. I just did that for our benefit. So I have to walk the line and then go, oh, what if it records my thing and I look like this? That tells me I started too far out, right? So I would have to come in closer to the CBR to start, and then I'd walk the line. Now what happens is we have to try to figure out what's that rate of change. Now the rate of change between those 2 points is a straight line, right? So that means that the rate of change is constant, right? All this stuff that we talked about the last few weeks is going to come in and be in handy for us here. Okay, so a constant rate of change. So it looks to me like I went about 5 feet, that's the change in my y's, right, my up and down, in about 4 seconds, or 5 meters actually in this case. Let's make it feet because that just seems ridiculous. Sorry. But it looks like I went about 5 feet in 4 seconds, right, because otherwise I'm going to be really running. Okay, so I need to be, what, getting closer to the CBR, right, so that it thinks I'm getting close. Now the likelihood of me being exact, it is a constant rate of change, so I'd have to kind of glide step and not be starting and stopping, right? But the likelihood of it being exact is a little bit off. So what a lot of people's graphs kind of look like is maybe like that. Okay, so then we'll try to focus on making our graph smoother and more closely being a constant rate of change there, following the actual graph. Okay, then what happens at 4 seconds? Yeah, I went back away from the CBR, right? So here's my CBR. I'm going away from the CBR. This is distance in feet from the CBR. That's the way you could think about it. Okay, so I'm going away from it. And it looks like I'm going from 5 feet to 15 feet. And the time here is even shorter. It's between 4 seconds and 6 seconds. Now, you can figure out that slope if that's what you want to do, right? So the slope, let me do that. M equals, the change in the y's is from 5 to 15. And it's going in a positive direction, right? So 10 feet per, this was only, the change in the x's was only 2 seconds. Right? Or that's 5 feet per 1 second. You are hustling to get from here to there, right? So you're going to be taking a little sprint to get over there. And hopefully going as nice and steadily as you can to try to get that. So that's really fast. This was only 5 feet. And by the way, it was from 10 to 5, so it was in a negative direction, right? M equals -5, and it took me 4 seconds. So that's about 1 1/4, okay, feet per second is what that is. All right, so then we want to talk about this last piece. I'm clearly coming back towards the CBR because the distance is shortening, right? Getting smaller and smaller and smaller. This is how far I am from the CBR, so this distance is shortening. And it actually looks like I have a pretty long time to do that. So it's, my slope here would be actually 15 feet. And I have from 6 seconds to 10 seconds to do that. So in 4 seconds. Okay, or 15 over 4, or if you reduce that down, 4 goes into 15 3 times, 12, 3 3/4 feet per 1 second, right? Okay, so this is a much more leisurely pace than what this was when I had to get there 5 feet in 1 second. So I can do a much more leisurely pace. It's not that leisurely. It's a lot more leisurely than if I had kept it at meters though, right? Okay, So you can see how the technology will help me, and the kids can kind of feel, okay, what does that mean, a constant rate of change? Because if they stop, by the way, what happens if you stop? What if I'm standing right here at 4 seconds and I just stand still instead of going away from the thing? What happens to my distance from the CBR? It stays the same, right? I'm still at 5 feet. I didn't move. But what happens to time? Yeah, time's still going, right? I can't control time. So as time ticks away and I'm standing still, this is no movement, right? So that would be 0 feet in however many seconds, let's say 3 seconds. So it's 0 feet per second. I'm not moving. That's a flat line right there. That would be a horizontal. And you can see where that zero slope comes in, right? 0 feet in however many seconds. It doesn't matter because I'm just standing still. So I can't just stand still because that'll make me have this constant of 0 right here for my slope. Instead, I got to hustle away from it. So it kind of gets the kids a little bit of a feel for what's going on. A lot of times they have to walk the same line multiple times. And if you guys were my students in a face-to-face classroom, I'd make you guys do it. And that way you could feel what your students would feel whenever you make them do these activities, which are a lot of fun and very hands-on, and let them know exactly what's going on with the slopes here and what's going on inside of these graphs. So some thoughts to think about. What if the graph had started right here? Well, at 0 time, I would be at 0 feet away from the CBR, right? So my object would actually be directly in front of the CBR, right? I would be blocking it, basically, and then I would get farther away or whatever. What does it tell me if it was down here at -5 when I started? That would mean what? Yeah, I'm actually behind them, basically, right? So it's hard to do that with a CBR, but that would mean I'm actually behind where the CBR. If this is the distance, or if this is where the CBR is, this is a positive distance away from it, this would be behind it. So that's kind of tricky. And then you can start talking about speed instead of distance. So speed is actually something that changes, right? That's a rate of change. So that gets a little more complicated. We'll talk about that some maybe later, but probably you've already dealt with this in a 361 or 362 class would be on thoughts. Okay, so those are CBRs. Everybody good? All right. So since we don't have that, I can work with you on calculator stuff so that we can look at some graphing things. We've already done a little bit of this work, but I want to just pull in some stuff that you've already done as homework type things. So you had an exploring houses homework, if you remember. And it looked something like this. There was the number of squares, right? And there was an X and a Y, and we already did this, so you can go dig it out in your homework or out of your notes or whatever. 1, 2, 3, 4, and we want to know how many squares, basically. House 1, house 2, so on and so forth. And what we found out was that we were adding 2 each time in our series or in a sequence. And so we saw that this was a constant rate of change, right? And we said, oh, that will be my slope. And so we came up with 2n. And we knew it wasn't 2n plus something because if I had gone backwards to the 0 guy, I would have had to subtract 2, and that would have been 0. So it's like 2n plus 0, but I don't need that little term in there. So I can just ignore the y-intercepts. We don't need them. Okay, so this is just the equation y equals 2n. And if we were doing our normal old algebra stuff, we would have rise over run. And that would be a 2 over 1. So every time I go up 2 on my y values, I'm going up 1 on my x values. Okay, so 2 in the rise, 1 in the run. Okay, so again, we can see that slope type thing coming in. And it would be nice if I could graph this. Okay, so you always know Dr. Webster's not an artist, so don't hold anything against me. But my points here are the point 1 and 2. Excuse me. And then I've got 2 and 4, and 3 and 6, and so forth. So if I just kind of scatter plot these guys, I can see it. I can see it looks linear. 4 and 8 would be even above that. By the way, don't draw the 0, 0 guy. We know he would be there, but he wasn't given, right? We don't have the 0 house with 0 squares, so don't do him. But we see a nice linear equation coming in there. Okay, so all of that stuff we've done in the past. And then we say, okay, how can we deal with that on our calculator? So we did a little bit of this before. I just want to reiterate that it's out there. Wake up, calculator. Oh no. My battery must have died on me. I even checked you before we came in here, calculator. Maybe he's just dead battery. Nope, he won't even brighten for me. Dang it. That is really weird. Yep, I can't use him. Dang it. Okay, so 21 minutes into this video. I'm not going to redo that. So I'll come back with that later. You remember that the way to do it is to go into your stat, edit your lists, and then you can calculate and just tell it what kind of regression. And on this one, we would want a linear regression. So I'm going to stop this, and I'm going to go grab another calculator. Dang it, I checked it before I came, but clearly I had it on for too long in here, or something weird's going on. And I'll be right back with video 2 for today. Sorry.